So we have to know the raw materials required in this extraction so that we can feed it into the furnace. There we have the ore, is also the raw material. We have limestone. So limestone is also called chemically calcium carbonate. Then another raw material is coke. Coke, that is carbon. So you realize that inside here we feed our raw materials. The whole, the limestone and coke are fed into the furnace. After feeding it into the furnace, we shall apply hot air. This hot air will give the furnace a temperature of 400 degrees Celsius. So when you get a temperature of 400 degrees Celsius, this hot air, they are going to react with unburnt carbon or coke to form carbon dioxide gas. Then later after forming carbon dioxide gas, we shall react. Carbon dioxide gas will react with unburnt coke to form carbon monoxide gas. Carbon monoxide gas, in its property, it is a reducing agent. It is a serious reducing agent. Therefore, the carbon monoxide gas we shall form will help us to reduce our ore. If it is hematite or iron or magnetite, it will give us our iron, which are then tapped later off. We shall realize that when we apply hot air here and burn coke will react with oxygen gas to give us carbon dioxide gas. Then carbon dioxide gas will react, the carbon dioxide gas which will be formed. Remember, there will be series of coke here. This carbon dioxide gas formed will react with unburnt coke or unburnt carbon to form carbon monoxide gas. So carbon monoxide gas is a strong reducing agent. Therefore, our purified oxide now can say iron oxide. This will react with carbon monoxide gas. And when it reacts with carbon monoxide gas, it shall form iron. The iron will be in liquid form, and then carbon monoxide gas. So iron dioxide was reduced by carbon monoxide to iron, and carbon monoxide gas itself was oxidized to carbon dioxide gas. Therefore, carbon monoxide is a reducing agent. Therefore, we have formed our iron. The iron form will be in molten form, please, not in solid state, because at a temperature of 400 degrees Celsius, iron exists as a liquid. It melts. Then we also have our impurity. We have to remove the impurity present. So to remove these impurities, limestone, which is calcium carbonate, due to the hot air present, heated, due to the temperature of 400 degrees Celsius, it will be decomposed to calcium oxide, which is also known as quicklime, and carbon dioxide gas. So the importance of this quicklime form, or calcium or calcium oxide, is to remove for us the impurity, the major impurity present, which is silicon dioxide. Calcium oxide formed will react with silicon dioxide, solid, to form calcium silicate. Calcium silicate in liquid form due to the high temperature. Calcium silicate, this is what we call the molten slag. So here shall realize that when we apply hot air inside, there will be some waste gases produced. There are some waste gases produced here, waste gases produced here. Here we apply hot air in. In real sense, this is not a waste gas. This same waste gas, it is still hot. What happens? It is recycled here. It comes back and still hit the furnace. Go away from here, comes back and hits the furnace. It just cycles in that manner. So when we form our molten slag and then our iron, when we form iron will be tapped from down, whereas the molten slag will be tapped from at a higher level than the iron. So they are tapped at different levels. This iron here is then taken further to industries and modified. And this iron here we have formed, we call it pig iron.